Welcome to your Skill 7 notes for the square root parent function. Okay, think about our parent functions, right? They all have a set of parent function points that we graph, and then we can apply transformations to. So the first thing that we need to identify is what parent function points will we use for a square root function? Well, normally, we've gone from -2 up to +2 for our x values. But there's a problem with that because we can't take the square root of -2. Okay, so we can't include that as an x value. Next, we have -1, and we can't take the square root of -1. So we can't use that as an x value. The next value we would normally use, pardon me, is 0. We can take the square root of 0. It's just 0. Okay, well the next value is 1. Yep, we can take the square root of 1. We end up with 1. 2 and 3 can definitely be taken a square root of, but they're not perfect squares. So we don't want to use those for x values. Let's use 4, because 4 is a perfect square, and the square root of 4 is 2. And we'll use 9 for x, because the square root of 9 is 3. In using these perfect squares for our inputs, we end up with beautiful corresponding y values, that we can graph. Sweet. So let's graph it. Now, if you're thinking, whoa, Patterson, square root of 4 is plus and minus 2. Not in this instance, because we're not solving an equation. We are evaluating an already stated positive radical. Okay, so good question, but know that that's not in this situation. Okay, plotting the points with me, please. We have 0, 0, 1, 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3. So we start at 0, 0 and extend out to include the other points. Your square root function should be curved, and there should be an arrow to show that it's going on into infinity. Sweet. Let's write down the characteristics. Well, h, k in this instance are both 0, 0 because we didn't shift right, left, up, or down. The x-intercept and the y-intercept are both 0, 0. The domain. Well, this function starts at 0 and then extends to the right. So we're going to say that x is greater than or equal to 0, or we would say inclusive 0 to infinity. Inclusive because we have a closed circle at x equals 0. Now the range also starts at 0 and extends up. So we're going to say that the range is y greater than or equal to 0, or for interval notation, inclusive 0 to infinity. Now, for increasing and decreasing intervals, if you need a reminder, it's always written with domain elements. Okay, it's always written with our x's. And why is because we're asking, where are the y values increasing or decreasing? Oh, our y values increase when x is this value all the way to that value. So if we look at this particular function from 0 to infinity, our y values are increasing. So we have an increasing interval from 0 to infinity. Never using a bracket. We're not talking about starting in one place. We're talking about an interval of space. So it increases from 0 to infinity. We do not have a decreasing interval. Is this function 1 to 1? Yes. It not only passes the horizontal line test, but it passes the vertical line test as well. What does that mean? For every x, there is 1 and only one y. And for every y, there is 1 and only one corresponding x value, aka the elements within the domain and range do not repeat. Okay, rate of change, well, it's exponential in a sense, so we say that it varies. This is not a symmetrical graph, so there isn't an axis of symmetry. Maximum and minimum values, well, yeah, this one has a minimum value because we start at 0 and extend to infinity. A reminder, maximum and minimum values are written with the range or the y values. So what's our minimum value? It's 0. We do not have a maximum value. Infinity is a concept. I would love to have an infinite amount of money in my bank account, but let's be real, that's impossible. So infinity is not a value we can reach. All right, and some of you will be happy about this. We do not have asymptotes. Okay, so ladies and gentlemen, there is your square root parent function. Okay, let's do a little bit of a review on our transformations. A is always in front of the function, and that could be your vertical stretch or compression, and it could be a vertical reflection. B, which is not written in here, so write with me please, is always factored out of the quantity with x. B is your horizontal stretch or compression and could be a horizontal reflection. H is the horizontal shift, and you have to take the opposite sign because in the quantity it's x minus h. And K is always the same sign because it's plus K, shifting our function up or down. Okay, so, gosh, I feel like we haven't done those in forever, huh? It was rational functions forever, and now we're back to transformations. It's good, though. It's good. Okay, so let's identify for our second example if we have an A, B, H, or K. It certainly looks like A is -1, which means we have a vertical reflection. Okay, B is just 1, so there isn't any transformation there. H is going to be -5. Again, we're taking the opposite sign, so we go 5 units left. And K is +3, taking the same sign, so we go 3 units up. Now, why does this matter? Because we have a transformation table for our points. And do a little flashback with me there also. It looks like this. B and H affect the x value. They're with x in the quantity, so to speak. So taking the reciprocal of B, we multiply it to x, and then we add and subtract h, depending on what our h value is. A multiplies to y, and then we add or subtract k, depending on what k is. That is the transformation table that we use for all transformations from the parent function. Okay, let's follow suit. We don't have a b value, so we're going to have x minus 5, since 5 is negative, and -5 is our h. And then we'll have -1y plus 3. Okay, we're going to take our parent function points. You guys can see it on your notes, but I can't see it on my screen. So as I've done so many times before, I'm going to write the parent function points next to the transformation table. There we go. And we're going to plug in all of our x values and plug in all of our y values to find the transformation table. Here we go. If we plug in 0 for x, 0 minus 5 gives us -5. If we plug in 1, 1 minus 5 gives us -4. 4 minus 5 is -1, and 9 minus 5 is 4. Just taking our parent function points and plugging them into our transformation table. Okay, so for y, if we plug in 0 for y, we get 3. If we plug in 1, we get 2. If we plug in 2, we get 1. And if we plug in 3, we get 0. Let's graph this. Remember, our starting point comes from 0, 0. So our starting point is going to be -5, 3. 1, 2, 3, 4, 5, 1, 2, 3. Okay, and then -4, 2. -1, 1. And 4, 1, 2, 3, 4, 0. Where do we start? We start at our starting point, whatever transformation point came from 0, 0. So I'm going to start at -5, 3, and then I'm going to curve to include the other points that I have graphed with an arrow in that direction. Sweet. Easy peasy. Lemon squeezy. Yeah, you're welcome. All right, HK. We identified it at the beginning, and it's in our transformation chart, is -5, 3. Our x-intercept is also in that transformation chart. That is handy dandy, so we can put that in our characteristic table. The y-intercept. Well, that certainly is not in our transformation table. So let's find it. We're going to have to find it algebraically. I'm just going to take y equal to negative square root of plugging in 0 for x, and I'm going to simplify down. So we get a negative square root of 5 plus 3. Now, the square root of 5 is irrational. Do not approximate this. We are not asked to graph it. We are asked to find it. We found it, so we're going to write it as a coordinate 0, 3 minus rad 5. Yes, you can write -5 plus 3. Oh, no, you can write negative square root of 5 plus 3. But I don't want you approximating, okay? Alrighty, Roo. The domain. It appears that we've shifted left 5 units. So our domain is going to say that x is greater than or equal to -5 or inclusive -5 to infinity. The range, however, because we do have that vertical reflection, the range comes from -infinity and stops at 3. So we're going to say that y is less than or equal to 3 or -infinity to 3 inclusive. Okay, because of that vertical reflection, our y values are now decreasing from left to right. So we don't have an increasing interval. We have a decreasing interval from -5 to infinity. Again, using the domain without brackets because we're talking about an interval of space, not, ooh, I include this point and I go to, no. Just an interval of space. Yes, it is 1 to 1. The rate of change varies. It is not a symmetrical graph. All right, that vertical reflection means we have a maximum value of 3, not a minimum value, and we don't have asymptotes in square root functions. So there, ladies and gentlemen, is example number 2. All right, we've got one more, of course. Dun, 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 dun. And this one, this one has a b value. Nice. So what do? We factor out the b value. Some of us still forget that. So write that down, please. In order to identify your h, you have to factor out the b value first. How do we factor? We divide. So dividing every term by -2, I'm going to say that -2 times the quantity of x minus 2 is our factored form. All right, so we've factored what we've needed. Now let's identify if transformations exist. Well, there isn't a value in front of the radical, so a is just +1. There's no transformations there. B in the equation is -2. And remember, I always write it as -1 times 2 to visually remind myself that I have 2 different transformations. We have a horizontal reflection from the -1. And in the transformation chart, we're going to take the reciprocal. So that means that we have a horizontal compression. We always take the reciprocal of the b value in the transformation chart. Okay, we do have an h. Taking the opposite sign, h is 2. So we're going to go 2 units to the right. And we don't have a k value, so there isn't a vertical shift. Let's go ahead and write out our transformation table. The reciprocal of b is going to multiply to x, and then we're going to add 2 since that is our k value. And nothing's going to affect the y values because we don't have an a nor do we have a k. Again, writing the parent function points right next to the table so that I have easy access to referencing them. And I'm going to plug them in. Okay, if we plug in 0 for x, we get 2. If we plug in 1, that leaves us with a negative half plus 2, so we get 1.5. Plugging in 4 for x, 4 times negative 1/2 is negative 2. Adding to 2, we get 0. And 9, well, negative 9 halves is negative 4.5 plus 2 gives us negative 2.5. Nothing's affecting our y values, so we have 0, 1, 2, and 3. All right, let's graph them. You gotta pick a color. Okay, so like it matters, right? 2, 0, it matters. And then 1.5, 1, 0, 2, and negative 1, 2.5, 1, 2, 3. Again, where do we start? We start at the point that comes from 0, 0. And then we go to include the other points. So I'm starting at 2, 0. I'm going to include the other points in a curve, and I'm going to have an arrow to show that I go on forever. Okay, here we go. HK, well, we identified it with the transformations. It's in our transformation table. It is 2, 0. The x-intercept is in the chart. Oh, it's not. Good catch. That's our y-intercept. Be careful. The y-intercept is 0, 2. So what's my x-intercept, you guys? Do we have one? Is it? Oh, it is in the transformation chart. Haha, it's 2, 0. If you were like, whoa, Patterson, it's in the chart. Good. HK can also be an x-intercept. HK can also be a y-intercept. There's no reason why not, okay? So don't dismiss that when you're identifying the intercepts also. Our domain starts at negative infinity because we have a horizontal reflection. So we should say that x is less than or equal to 2, or if we're using interval notation, we go from negative infinity to positive 2 inclusive. We don't have a vertical reflection, so we're going to start at the k value for the range, and we're going to go up. So y is greater than or equal to 0, or inclusive 0 to infinity. Now, we did have a horizontal reflection, which caused our y values to decrease. We have a decreasing interval from negative infinity to negative 2 non-inclusive because this is an interval of space. Okay, 1 to 1, heck yeah. Rate of change varies. Axis of symmetry, nope. Maximum and minimum values. Again, there wasn't a vertical reflection. So we have a minimum value, and it's always the k, it's always the range, so it's 0. There isn't a maximum, we just talked about that, and we don't have asymptotes. All right, that was a pretty mellow third example, huh? Okay, ladies and gentlemen, that is your square root function. Be careful with the index, okay? We're graphing the square root function. Nice, good job.